Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to go over your Unit 11 concept on capacitors. A capacitor, formal definition, two parallel plates that are separated by an insulating material that we call a dielectric. So capacitance, the symbol for a capacitor is what we see here, and units for capacitance are going to be in farads. Two equations that we would use to find the equivalent value of resistance for both a series connection and a parallel connection. Capacitors in series, C equivalent is equal to C1 multiplied by C2 divided by C1 plus C2. If I have more than two capacitors in parallel, C equivalent now becomes 1 divided by 1 over C1 plus 1 over C2 plus 1 over C3. If we have a parallel combination of capacitors, C equivalent is equal to C1 plus C2 plus C3. I hope you recognize how these equations look like what we saw for resistors in series and parallel, but they're just exactly the opposite. Remember when we took a look at resistors in series? We had R1 plus R2 plus R3. And when we had resistors in parallel, R1 times R2 divided by R1 plus R2, or if there were more than two resistors in the circuit, 1 over C1 plus 1 over C2 plus 1 over C3. So kind of an easy way to remember this, resistors or capacitors in series add like resistors in parallel in terms of how the algebraic expression works, and capacitors in parallel would add like resistors in series algebraically how the expression works. Also, I would like you to keep in mind that a capacitor stores a charge. So we apply voltage to a capacitor, and the capacitor retains that charge for a certain amount of time, and the charging and discharging curves that we assign to a capacitor are exponential in nature. They are not linear. And then the final concept to keep in mind, we saw this a little bit last week when we talked about different types of loads in an AC circuit. Remember we talked about inductive reactance and we talked about capacitive reactance. Well, capacitive reactance, remember what the expression was. X sub C is equal to 1 divided by 2 pi multiplied by the frequency multiplied by the value of the capacitor. So what we find in the case of an alternating current circuit with the capacitor, frequency and capacitance are now inversely related, meaning as we increase the frequency, we decrease the capacitive reactance. As we decrease the frequency, we increase the capacitive reactance. So please take a look at the PowerPoint for Unit 11 and read through your text. And everyone have a great week, and we'll see you next week.